Hey there viewers, welcome back to Ray of All Trades. Today we're going to be working on my Dewalt 18 volt drill. It's got the hammer function on it. Just all of a sudden stopped working. So replace the battery and let's see if we can dig into it and see what's going on with it. First things first, let's just verify that this battery is good. Try all different settings. Let's go forward, reverse. Let's try the gear selector. It looks like the gear selector isn't going to work until the motor actually tries to turn. There we go. I was able to get the gear selector to turn just by spinning the chuck a little bit. I think that this is a brushed design. I don't believe this is a brushless design. And let's try to pull this cap off the back and see if it exposes some brushes, and we might be able to take a voltage reading, see if it's actually reaching the brushes. T10. And in fact, this is the brush design. Here's the brushes right here. Got one on this side and one on this side. I should be able to take a voltage reading from this side to this side, and with the battery on it and the trigger depressed, I should have 18 volts up here. Let's see if it's even reaching the brushes. Meter on DC voltage. Let's use a jumper wire so that I can have an extra pair of hands here. So one's going to be on this brush on that side. There's that brown wire there. Wrap it around this side of the meter. And if I pull the trigger, there's a chance that it might go. We're playing with live voltage here. There's a chance it might actually go when I press on this. So. Okay, I've got nothing occurring here. Pulling the trigger. So I've got no voltage reaching the brushes. So if no voltage reaching the brushes, it's definitely not going to go. So my second guess is going to be a problem inside the power switch. So let's pull the whole front driver assembly off. 4 T10s. There's the whole front assembly. It's got a keyway. If you're ever taking this apart, just make sure you get some grease back in there. So the 4 T10s takes that out, and then I should be able to pull this plastic assembly apart. I'm trying to remember if you have to cut the rubber grip or not. Let's find out together, shall we? Planetary gear assembly came out with it. So it looks like that rubber grip is already split, which makes me happy. I don't have to cut the grip. Okay. Just pull that part of the assembly out. Okay, what I should be able to do right now is very carefully, again we're playing with live voltage here, plug that back in. Let's pull this selector switch out of here just in case this thing kicks. When I pull the trigger right now, if this trigger assembly is good, I should get voltage across those two wires, and based on what we just saw, we should get power to these two brushes. So these two wires just go straight up to these brushes. And if you ever need to change these brushes, you would just pull this spring out, pull the brush out, and it unplugs from this wire, and you can just change the brush. So let's take a look and see what's actually occurring here. Okay, nothing's occurring there. Let's make sure we have where we have voltage and where we don't have voltage. So right now, across the battery, careful not to touch the body of the switch. I don't see voltage right there at the connector. It's kind of funny. I have voltage there. When I plug it in, I don't have any voltage. So is it possible that the lithium pack is being told to shut down because of a problem with the switch? Or do I just have a bad connection right here? Let's get a couple jumper wires and find out what's going on. Go ahead and make a couple quick jumpers. Let's get on there. Insulate these from each other. I've got this rubber boot that's insulating the two from each other. Put one of them right on the meter and the other one right here. I should get, yep, 19 volts. Okay, which means that if I've got one right here on this side of the switch, and I have the other one, let's go ahead and put a meter on there real quick. Alright, so we agree I've got 19 volts sitting on the end of here to here, right? So if I touch this to that battery, it sparks and shuts down. Which means that there's something wrong. It's either a dead short or something inside this switch. Ooh, they got warm. Okay. So something wrong with the switch. Let's disconnect this for the time being. Yeah, the cable's got warm too. There's a direct short on that switch. There's definitely a direct short, and that battery is attempting to save itself by shutting itself off. It has a circuit inside it. That is made to shut itself down. Let's see what we can figure out with this switch. just for giggles. Let's find out if it's the motor that's shorted or the switch that's shorted. Alright, so it's definitely the motor is okay. There's something wrong with that switch assembly. So my brushes are okay, my motor is okay, battery's okay. The meter itself should not be shorted. So let's see. So if I do put the leads together, I've got close to short, right? So if I just push the two through there, I don't believe I should have a short. There's my 419 ohms. If I let go up, I've got a short, and I don't believe I'm supposed to have a short. This side of the switch doesn't change, which means that side of the connector doesn't change. This side likely doesn't change. Alright, so we've proven that this goes straight down to each one of those no matter what you do with the switch. And that means if I touch these two, that means I've got a direct short as well. Yep. So squeeze the trigger. Trying to figure out how I can get this apart. It's trying to move. Looks like some heat sink compound on this side. Kind of looks like these four are soldered through, and I'm not sure. If I had my desoldering station, I could just buzz these real quick, and I don't have one here at the house. So I'm fairly confident that that's how I'm going to have to take this apart. It's going to be to desolder those. Went digging through my old junk drawer and remembered that I had a desoldering iron, an old Radio Shack style. Anyway, it's got a hole in the middle of it. It heats up like a regular soldering iron. What you do is you squeeze the bulb, you melt the solder, and then you let go of the bulb, and it sucks all the solder in, and then you squeeze the bulb again and shoot the solder back out. Let's see if we can make it work. It's been sitting here heating up for about 5 minutes or so. If I remember, it was actually very slow to use. So squeeze the bulb. See if you can melt the solder. I'm also moving it around in a circle to try to get it all melted. Pulled some of it off. Could be a lot of metal in there. Either I'm not hot enough or this has got way too much metal in it. I'm getting a little bit to melt in there. There's another trick you can do, and that is to put some fresh solder on it. It does a couple things. It heats it up. It also adds fresh solder for it to flow better, and it gives it more surface area for this to actually touch. Get a different iron good and hot. Got that one. Squeeze the bulb. Got some of it. That iron I was trying to use is a little bit too big. Tried to melt the plastic. So I'm just using the desoldering iron to try to heat it up. Did pull a lot of solder out of there. I don't know if you guys can see, it actually did pull quite a bit of that solder out of there. And I can tell you that this heat sink is extremely hot right now. So they are connected. I'm not sure if this thing's going to allow me to take it out of there, because if there's any solder at all holding on, and I'm positive that there is a little bit, it's going to fight the entire way out. So let's see. I'll start with a wedge in there. Well, looks like it's trying to come out. So that one, the pin has come down quite a bit. I don't think I need to keep using the bulb, you know, to try to pull solder out, because it's not really pulling anything, but heating up the pins in a circular fashion does seem to be helping. Looks like the top ones have been pulled loose. I did notice is this soldering iron, the desoldering iron, is getting really hot. I wonder if I can pull more solder out of there. I think all it's doing now is wrecking the plastic. Oh yeah, there's a PC board under there. a bunch of surface mount devices, our chances for recovering this thing just got a lot smaller. I wonder. Not that it would have helped me much, but it looks like this plastic comes apart. And hot. Let's see. I'd like to know if this thing would have come apart without messing with all that. Probably not. It looks like it's... This way I can show you guys what it looks like if you ever want to try to take one apart. This one's a lost cause. I'll show you why. Ignore all the carnage, right? Once I saw what I was after, I just went ahead and just started yanking on the dang thing. Inside here, there was solder traces that go all the way through to these contacts here. What I was able to look at when I was looking down there is, let's see if you guys can see this, and I don't want to burn my hand on here. So I'm going to say that they're going to probably call this a non-serviceable part. Anyway, so this right here is likely a power transistor. I see a whole lot of black smoke here. So either one of the traces on the board burned up, because I just yanked this off of here, so this trace I can't even tell you if it's there or not. So either that or this component right here, which I can't really tell if it's a diode or a resistor. Looks like a germanium diode, that orange with the black stripe on it. But either that or maybe that resistor. Anyway, something fried, and likely this transistor shorted. Which when that transistor shorts, very likely that output transistor with the heat sink attached to it would have likely been our culprit. I'm going to say non-serviceable part. If I had better tools at home here, you likely could have heated this up. Look at the size of the traces there, and all of that wire goes directly back to this heat sink. If you could have heated that up, you could have likely separated the plastic to pull the pieces apart. And then of course all of the springs and triggers and everything else that's flying apart right now, obviously save that. If you can find this board to try to fix it. Mine, like I said, was not a trace. I was kind of hoping it was going to be a trace and I'd be able to fix it, put it back together. As it stands right now, I got to buy a trigger assembly. Then I'll try to put it back together. I'm hoping that the trigger assembly does not cost as much as an entire drill. I'll jump online, see what I can find, and hopefully I can put my Dewalt drill back together. Looks like I found it. It's a Dewalt replacement VSR switch, part number 152274-25SV as in Sierra Victor. They want $87, but hey, free delivery with Prime. $87 for this thing. Yeah, I'm going to be looking for another drill, worn out, something like that, that maybe I can steal the trigger switch out of. Maybe just replace this clutch on the this drive on the front. So, because I've had to replace this already one time before and get it all cleaned up. This is a pretty old set. I've been very happy with it up till now. It's definitely paid its dues. It's earned its keep. Let me see. This video may end right here if I can't find a replacement. Hopefully this helps you guys figure out exactly how to diagnose your drill, how to get it apart. If you guys got anything out of the video, really appreciate a thumbs up. Subscribe helps the channel tremendously. And I'll catch you on the next one. Thanks.